All right. Hey, everybody. My name is Abdullah Syed. I'm an undergraduate statistics major at the University of Missouri, and I'm going to be presenting on the implementations we did with Parsl this summer with my research group at the University of Illinois.
Are you sharing your screen?
Oh, shoot. Am I? Oh, I might not be. 1 second. 1 second. I could have sworn it was. Okay. Here we go. All right. Is that it?
Yeah.
All right. Sorry about that, everybody. All right. So yeah, once again, what we primarily worked on was augmenting workflows, cancer data processing workflows, although the work we did could also be used for a lot of other different kinds of scientific data processing workflows. So yeah, let's begin. So here's a little bit of context for everybody. So evolutionary relationships as well as the growth of tumors over some period of time, right? And phylogenetic workflows are the pipelines that are used to build phylogenetic graphs to represent those evolutions, and over time by processing a lot of genomic and mutagenic data in a multi-step process. And these are often utilize WDL, which is a workflow description language, which is a bioinformatics framework that's used to execute these workflows. And the one we primarily worked on and augmenting with Parsl was Phyloflow, which made really heavy usage of this. So yeah, we implemented solutions through Parsl, which I mean, we're at Parsl Fest, so I don't think I need to explain that any further. Yeah, though. So here's the basic overview of a Phyloflow. Here's the steps it takes to generate the. It loads in the initial data file and its annotated version, and then it converts that into the required input format for the next processing step in it, and then executes that and uses a combinatorial algorithm to cluster those mutations, based off of similarity, and then it adapts those into another workflow processing step, and gathers all the relevant output files and merges them into a JSON document or a JSON file that is compatible with a Phylodiver, which is a visualization tool that's used to display those phylogenetic trees. So why translate the Phyloflow workflow into a Parsl format? So we primarily did this to compare the ease of use of Parsl against WDL on a scientific workflow, as well as extending the workflow's capabilities, which we did to make it able to process significantly larger workflows or significantly larger data sets and execute those on the supercomputer clusters we use, which is primarily HAL as well as Delta at the University of Illinois. And we also use it to make it easier to integrate large language models developed, primarily for Python-based frameworks, right? And okay, so here's a little bit more. So here's how the translation process went. We primarily figured out the Phyloflow workflows, tasks, and dependencies, and we set those up in Parsl. As well as that, we tried to run the workflow in local environments as well as on the supercomputing environments. So we translated all the different tasks, which were like the workflow steps individually, like the PyClone V step that we PyClone V step, and as well as Jupyter clustering steps that we went over, or Juniper clustering steps that we went over earlier. We translated those into different Parsl apps, and we also translated those bash scripts into the bash scripts used to execute them into Parsl functions. And yeah, essentially we got the process down here too. That's a little bit of a better overview. Oh, my bad. Sorry about that. Okay, sorry about that. And yeah, so here's overall how it went. So we had a few advantages. Of course, it allowed us greater control over the varying dependencies that a workflow like Phyloflow was built on. And we found it a lot easier to work with because, well, Python environments, especially in the context of data processing, was a lot more familiar to us than WDL was. So that was just that just made things significantly easier. But the greatest advantage was the easy parallelization and expansion of the workflows that Parsl allowed us to do. So disadvantages were it requires a little bit more experience with certain file systems, and if you have like different conflicting dependencies in the background, operating at the same time, it can, cause more points of failure, but that was honestly more of a time constraint than anything. We only had a summer to work on this, so I don't think that's really a huge long-term issue. And retrieving inputs and outputs by indexing arrays was also error prone, but again, I think that was just things that could be worked out, hashing out the logic a little bit better over a longer interval of time working on a project like this. So here, and what we also did is we also tried to augment this workflow with large language models. So we primarily used OpenAI's API to do this. So here's a little bit of a diagram as to how we went about doing this. So we primarily used function calling, which is a fairly new feature, which allows OpenAI to directly, based off of user input, execute some program, right? So we primarily use this to process the data steps in those steps listed before, but it creates a lot better of a user experience by allowing you to just use natural language to input that and just have the OpenAI process that for you. So here's essentially a little bit of a diagram as to how exactly this is implemented via Parsl, and how OpenAI actually executes each of those workflow steps. I suppose I could go over it. All right, so here's a little example as to how exactly that looks when it's implemented, and as well as that a little bit as to what other steps we could do in the future, or for anybody else to work on in the future. So here's essentially you give it some context, like for example, if you're asked to execute a single task, you will input these two like commands, right? Transform that file into the format required to process it through the next step, and then it invokes that function directly to process that for you, as opposed to having to manually do a lot of that. And I think that's pretty incredible. And yeah, that's about it. Yeah, this is our references here, and that's about it for
Right. Accurate timing within 5 seconds.
Let's go.
So, any questions on here?
Yeah.
So in your language thing, are you calling functions on HPC resources using Parsl for that, or is the LangChain in a different?
LangChain is basically a connector between OpenAI as well and our program. It essentially serves as an intermediary to allow OpenAI's API to analyze our program, as well as potentially, well, we didn't really get to executing anything with it. All it really could do is analyze it. So we weren't actually able to execute any of the program's functionality with LangChain. So we ended up ditching that, especially once I believe function calling rolled out around the same time we were working on the project. So we were able to actually get that done with that. So LangChain essentially, even though it's in there, it didn't really play as huge of a role as we initially thought it would. Anything else?
No.